Alright, this video is to accompany our Precalculus 12 class, and it is a quick rundown for our final project, the Desmos Project. So, in essence, what we're asking you to do is to come up with a drawing, and then once I approve your drawing, I'll give you little initials on your paper. What you do is graph that sucker in Desmos. That's in a nutshell what we're doing here. A couple things. Let me just throw up the rubric that we're looking at. So in Precalculus 12, there are about 12 parent functions that we talk about. And one of the big parts of this course is looking at transformations. So can you move it left, right, up, down? Can you stretch it? Can you compress it? Can you rotate it a little bit? Also talking about domain and range. Fine-tuning our understanding of those words, and then how to do that in Desmos. And so you may notice there's more than 8 functions, but as long as you have 8 of those parent functions that are somewhat transformed, you get a point for each of them, up to 8 points. Similarly, for each parent function with a domain or range restriction, you can get a point up to 6 points. So, for example, if you have an absolute value function that's transformed, I moved up and to the right, and it's got a domain restriction, like you can make it just a v, for example, by limiting the domain. That would count as a point for a parent function and a transformation, and then a point for a domain restriction. That's 2 points with one equation. Also, you can earn a couple points by how accurate your drawing is, how accurate your Desmos graph is to your drawing. You can earn a few more points based on how complex your drawing is. And so, again, that's the part that you want to get pre-approved ahead of time. If I sign off that, yeah, this is complex, then you're good to go. In general, so far, most students have interpreted complex as being lots of detail in whatever you're drawing, or having some kind of moving element. Brian Chow having a Thor's hammer with clouds that move in the background, and then other creative ideas. Anyways, and then also you could do function compositions for some extra bonus points. And when I say bonus, I don't mean extra credit. I mean, like, just more points. So you could add, subtract 2 functions. You could multiply 2 functions. You can make a rational function out of 2 functions, or you could put a function inside of another function. And so, if you, like you could put a sine function inside of a log function. That's function composition. You could do a log function divided by a polynomial function. You could do a whole number of things. You could put a sine function inside of a circle equation. What the heck would that look like? Go crazy. Ultimately, if you add all the points up, it's 25 points possible for this project. I'm assigning this project now, week 17, second to last week of semester, because I understand that you have other final projects, tests that you're studying for. So I want to give you 2 weeks. It's not due till last day of school. 2 weeks to work on this, so you can kind of decide how does this project fit into your schedule with your other final assessments. The bonus of turning it in this week is that I can grade it this weekend, and then you can make edits and resubmit for a better score next week. Or you could just submit next week and see what you get, and that'll be it. After next week, though, June 10th, last day to turn it in, whatever grade you get at that week is your final grade, and you're good to go. Anyways, good luck on your projects.